Hello everyone. We were in model number 3 of computer communication network and we were dealing with network layer. So in the previous lecture we have started with introduction to network layer and we have seen some of the services or the task performed by network layer. We have seen how the network layer will provide services like error control, flow control, congestion control, security, and quality of services when the data communication takes place. So, with this, we'll move on to the next part of it, which deals with packetizing, routing the data to the destination. First, we'll see how the communication occurs at network layer at the outset. So you can see in this diagram, so there is a communication from one source to one destination. So in this case, we have taken a communication between Alice and Bob. So the connection is established through many network. You can see here, you can see one two three different networks are there in between the source as well as the destination. So these are connected through the connecting devices such as routers or switches. So we can say this as a internet where it is a combination of LAN and WAN. As we can see in this diagram, the communication between Alice and Bob will take place through the source host, destination host, as well as the routers in the path. So we can see here we have router R2, router R4, router R5, as well as router R7, which will be linking the source as well as the destination. At the source, that is according to this diagram Alice, the network layer at the source host takes the data or accepts the data from the transport layer, and whatever the packet it is going to get from the transport layer, it will encapsulate in a datagram, and then it will give it back or it will deliver it to the data link layer. So once it is received at data link layer will do the necessary operation as we discussed in the previous chapter, and it will move to the physical layer. So physical layer, through physical connection or through the connection, it will reaches or it will send the data to the destination through different routers. At the destination, whatever the datagram is sent, first it will be received at data link layer and then it will be moved to the network layer. At network layer, the datagram is decapsulated and the packet is delivered to the corresponding transport layer. So whatever we said, this decapsulation is the exact operation which is opposite to the encapsulation operation occurred at the sender end. So please note, so whatever operation occurs at the sender end, the same thing in reverse will occur at the destination point. So there is a link between the sender as well as the receiver. Now we'll go in depth and we'll see what is this encapsulation, how it will be done, so how it will be forwarded, how will be routed. So the first part of this is called packetizing. So the first duty of a network layer is packetizing, that is encapsulating the payload in the network layer packet at the source and decapsulating the payload from the network layer packet at the destination. So it is one of the duty of the network layer to carry the payload from the source to the destination without changing it or using it. So network layer is doing the service of a carrier. So as similar to our normal post office. So carrying the data from one place to another, which is the responsibility of a postman. So similarly here the network layer will carry the data from sender to the receiver without changing the content. The source host receives the payload from the upper layer, that is the transport layer. So once it is received, it is going to add an header, which is nothing but it is a information which consists of a source address as well as the destination address, and it is going to add some of the data or the information which will be required by the network layer while transmitting the data from source to the destination. The source will not be allowed to change the content of the payload which is received from the transport layer unless the data is very huge or it difficult to send. So what it is going to do is, so it is going to perform an operation or something called fragmentation. So if the data or the payload whatever we call received at the network layer from the transport layer, if it is very large and difficult to transmit in one go, then it is going to divide that payload into different number of frames. That is called as fragmentation. At the destination, the host receives the network packet from the data link layer. It is going to decapsulate the packet, that is going to remove the source and destination address and deliver it to the upper layer, that is at the destination the data will be moved to the transport layer. And whenever the packets are fragmented, as I said, if the data is very large to handle, then it is going to divide it into number of frames. So if this happens at the source or in the router, then at the receiver end, the network layer has to wait till it receives all those frames. So once it receives all the frames, it is going to rearrange everything, that is it is going to rearrange all the frames. Once that is done, then only it will be delivered to the transport layer. However, routers in the path are not allowed to change or decapsulate the packet unless packet needs fragmentation. So routers will not have right to change the addresses in the datagram, or it will not fragment the data unless it is instructed. Even they are not allowed to change the address, as I said before, they are not allowed to change the source as well as the destination address. So this is called as packetizing, that is taking the data from the network transport layer at the network layer, form a packet, add the header, then add the source and destination address in that header and transmit to the receiver end. At the receiver, it has to receive all the frames. If it is fragmented, arrange it, then give it back to the transport layer at the destination or at the receiver end. So when the packetizing is done, the next work is routing the packet and forwarding the packet to the destination. So the next one is we call it as routing. Uh, the network layer, as I said, is responsible for routing the packet from its source to the destination. However, whatever the network is formed is a combination of networks So it will consist of LANs, WANs, and this will be connected through routers. So we might have more than one routers which will be connecting the source and the destination, and network layer is responsible for finding the best among the possible routes to reach the, or to make it reach the packet to reach the destination. In order to make, or in order to see to it that the packet has reached, or to make the packet to move in best possible way, the network layer has to have some specific strategy to identify the best possible route. How we see in normal traffic, if the traffic is more, we people will take the shortcut, or any other way wherein the traffic is less. In the same way, network layer has to see is there any multiple path for the destination, and it has to see the congestion in that particular path, and based on that it has to route the packet. So this will be done by network layer using some strategies. So this is nothing but by using some routing protocol which will help to send the packet in the best way, and also it is done through coordinating with neighboring nodes. So in order to route the packet in the best possible path, the router has to forward the packet. So in other word, which is called as, we call it as forwarding. So forwarding can be defined as an action applied by each of the router when packet arrives at one of its interface. So whenever the packet arrives at the router in any of the interface, so how best, or the what is the action taken by the each router is called as forwarding. So to move the packet forward, a decision making table is normally used by the router. We call this as a forwarding table or as a routing table. So this will be maintained by all the routers, wherein it will have the information of the forwarding path as well as output interface. As you can see in this diagram, data has been come to this particular router from the source B, right? So once it has come, so it has come from say A, and it is destinated to B. So once it has arrives at the interface 1, it will see what is the path for B. So according to this forwarding table, the output interface for output source B is 2. So it is going to send the packet through the interface 2. So each of the router will be maintaining this forwarding table, or we call it as routing table, wherein for each of the incoming frame it will have an entry for outgoing interface. So that will be seen, or that will be referred by the router, and then it is going to output the frame in that particular interface. So from this two, that is from routing and forwarding, it is something like whenever the routers receive the data, so some kind of switching operation need to be taken place, because so it has to see which path is free. According to that, the input as well as outer output has to link. So something called switching operation need to be take place. So in case of computer communication network, we have something called circuit switching as well as packet switching. So we'll see what is this packet switching or circuit switching. The circuit switching is nothing but switching from one input to connecting it to the output, and this will be done in physical layer, whereas something called packet switching, which will be done in network layer, as I said, based on the input and based on the output at the router, it is going to decide which is the best possible way, and that will be switched. So that will be linked for a packet. So we call that as packet switching. As we discussed before, in case of network layer, the message from upper layer is divided into packets and sent through a network. The source will send the packets one by one, and at the receiver or at the destination, the packet will received one by one. So the destination has to wait till it is going to receive all the packet of the same data, and once it is done, then it will rearrange, because some data might arrive late even though it has been sent first. So it has to be rearranged, put it in a proper format, and then it will be given to the transport layer. The connecting devices in the packet switching network still has to decide how to route the packet to find to the final destination. So as I said, it has to see the best possible path for the packet to reach the destination, and this will be achieved in two different ways. That is, in packet switching network, it uses two different approaches to route the packet from one place to another, that is from the source to the destination. First one we call it as datagram approach, and the second one we call it as virtual circuit approach. So we'll see what is this datagram approach as well as what is this virtual circuit approach. The datagram approach, usually we call it as connectionless service, that is we take it into consideration of connectionless network, whereas the virtual circuit approach will be applied wherein there is a connection oriented network. So we'll see the datagram approach first. As I said, it is a approach for a connectionless service. Initially, when the internet was started, network layer was defined to provide connectionless services, so that each packet is treated independently, that is separate packet, with each packet is having no relationship with other packet. So in this approach, packet in a message may travel in the same path to the destination, or they might take different path based on the traffic in the channel. Let us take this example. You can see here the network layer has got a frame from the transport layer. So that has been divided into or fragmented into four different frames, and this is the source and this is the destination, and this is the network. So if you see this network, we have router R1, R2, R3, R4, R5 in between the source as well as destination. So there is a multiple path exist between the source and destination. So the packet might go through R1, R2, R5 and reach the destination, or it might take R1, R4, R5 and the destination, or it might take R1, R3, R4, R5, or even it might take R1, R3, R4, R2, R5. So there is a multiple path available from the source to the destination. So as we said, there are four data which will be sent from source to the destination. So since this is connectionless service, so the packet will go from source to the destination in any possible path based on the traffic. So see here, the first packet has been sent, followed by second, followed by third, then the fourth. So the packet 1 will come to router 1. So what router 1 do is, since it finds this path is free, so it will forward that packet to router R4, and from there router R4 sees that this is the shortest path or the best path, and it will forward to R5. From there it will be forwarded to or sent to the network layer of the receiver. So similarly the packet 2 will come to R1. Now instead of sending it to R4, here it will forward it to R2. From R2 it will come to R5, and then it will go to the destination. Similarly the frame 3 will come to R1 first, from R1 to R3, then to R4, and finally to R5 and to the destination. If I take frame 4, it is the path is to R1 first, to R3, then R5, then to the destination. So as you can see, the data has traveled in many ways. The data has followed or taken different ways. So if you see the destination here, frame 2 has reached first compared to frame 1. So we have got frame 2 first, then we have got frame 4, then frame 3, and lastly we got frame 1. So even though there is multiple path possible between the source and the destination, so depending upon the best possible route, the packet will be sent. So it does not mean that whatever the frame has been sent from the source, in the same way it is going to reach to the destination. So it will be any order. So you can see the frame whatever we received is out of order. Even though we have sent 1 2 3 4 in the order 1 2 3 4, we have received in 2 4 3 1. So each packet in the route will check the address or the information in the header, that is the source as well as the destination address. So router will find or route the packet based on the destination address. So source address and the destination address will be available in the packet. So it will see the destination address, and based on the forwarding table it is going to forward the packet. So as we can see here, so for each of the destination there is a outgoing port here. Okay, so based on the destination address there is an output interface. So looking at this particular output interface table or the forwarding table, the packet will be sent to the destination. So when the packet arrives at this particular router, first it will check the source address as well as the destination address. Based on the destination address it is going to see the which interface is free, so through that it is going to send. In the case of frame 1, since this interface is free, so through this particular channel or through this interface it will forward it to router R4. At router R4, once again it has got 3 outgoing port here. You can see this is to R2, this is to R3, and this is to R4. So based on the traffic available, so it will pass that packet or the frame 1 to R5. So once again here, the only possible way to the output address specified or the destination address specified is this path. So using this particular path it will be sent to the destination. So one thing to be remembered, so destination address in each frame will be checked by each of the router, and based on that the packet will be sent. But you might think, why, what is the use of the source address? See, the importance of source address is, one thing is to know from where exactly the packet is originated. Second thing is, whenever the packet is lost or discarded by the destination, then the source has to come to know that the packet has been discarded. So whenever the packet has been discarded, our error message will be sent to the sender. So we'll use this particular address, source address, to send a error message whenever a packet has been discarded from the receiver. So this method is called as datagram approach, wherein the given packet will be divided into small number of packet or the frame, and it will be transferred from the source to the destination. And whenever this happens, so the in between router will decide which is the best way based on the forwarding table, and looking at the interface which is free or which is less traffic oriented, in that particular path the frame will be sent. And more importantly, we have to note that what are the frames sent at the sender, in the same order we may not get the data at the receiver end. So it might be or it will be in out of order. So network layer has to wait till that it receives all the frames, and once it is received, it has to rearrange in the same way how it has received at the network layer of the sender from the transport layer. In the same way, it has to rearrange, it has to decapsulate, that is, it has to remove the receiver address as well as the sender address as well as the additional information which has been sent for routing purpose, and then combined together it has to give it to the transport layer for further operation. Hope you are clear with packet switching in that datagram approach. So with this, we'll move on to the second approach, which is called as virtual circuit approach. Circuit or a virtual circuit approach is nothing but the connection oriented service, wherein it takes the packet in a same way or the same path how a one frame has been traveled. Here we have seen it will take any possible path, wherein in case of virtual circuit approach, once one frame has been sent in one particular route, rest all of the frame will pass in the same path. So we'll see how that happens in the next video. So hope you are clear with today's or these video topics. So we started with the introduction to network layer, wherein we have seen the packetizing of a data received from the transport layer, followed by routing the packet and then forwarding the packet to the destination. So in that we have seen two different approaches, that is switching approaches, that is packet switching as well as circuit switching. So circuit switching which deals with physical layer, whereas packet switching in network layer. So in this we have seen the first approach, that is datagram approach, which is used in connection less networks. So we'll move on to the next approach in the coming video lecture. Thank you.